All right, so let's talk about yesterday's do now. I'm going to go over and review it, rewind, fast forward as you need, whatever. So it says graphing linear equations. It wants us to write the equation of given lines in the quadrant below. So let's take a look here. Got my writing tool out. I'm going to use red. So we have line A here. Does it start at the point of origin? Big hint already. Okay. We have line B here. That thing's moving in a negative fashion. Big hint here on that line. And then we have letter C. That thing's starting at the point of origin there. 0, 0. Big hint on that line. And then we got the flat liner right there. Just stuck on one spot on the vertical, which give us a tip there. And then we have another line here that's stuck on the horizontal axis. So let's talk about some of our equations here, the ones we're going to deal with here. Then you'll talk about the constant proportionality equation, all right, which is y equals the constant, or k, which is really our rate of what? Change times x. In this situation, there is no point of, in this situation, this starts from the point of origin when we have these type of equations. So you'll see how this constant proportionality equation is really important when it comes to letter C. Let's talk about the other equation from that we're used, slope-intercept form. So write that down. So I have my constant proportionality here. Let me constant of proportionality. Gonna get a little sloppy there. So that's the equation there. And then over here we have our what? Our slope I'm gonna run out of space here. Intercept form. All right. This being our y-intercept, this being our rate of change, and this being our x value that gets influenced. All right. So we have those equations there. So let's take a look at letter A. Well, it don't start at the point of origin. So we know what? It's not going to be that equation. So let's take a look at this one here, the slope-intercept form. That's pretty nice. So I'm going to put the form of the equation over here. I'm going to go y equals, I don't know the slope yet. I don't know the slope yet for A. But what I do know is where it strikes the y-axis. Strikes at 0 on the x, and it strikes at 0 to 3 on the y. So all I'm going to do is put my 3 there. We're really concerned about the y-axis and not so much the x. Make sure y'all understand that's a y. So the y-axis there, you get the idea. So, well, let's take a look. We still got to find our rate of change or our slope. So let's find our slope. All right, so we are letter A. So I'm going to start here. I'm looking for a right triangle of some sort, and I've got one. Oh, Mr. U, that's not perfect right triangle. Hey, man, we're not trying to rescue people stranded in the woods or anything like that. So this will work, okay? So notice my right triangle here. I got some movement on my y-axis. You could see in a sense if I was extended out, it'd be the same thing here, that movement on the y-axis. And I got some movement on my x-axis here. So we know that slope is really the quotient of the rise and the run of a line, the movement of a line, however you want to see this. So let's talk about our run first. All right, so I'm here, 1 increment, 2 increments, 3 increments to get where I can form that right triangle there, or right angle here in the situation. There are 3 increments, and what are the values of every increment? Is 2. So 3 sets of 2, we got a run of 6 here. Okay, so our run 6. Okay, cool. Let's go ahead and take a look here on our y-axis. We're not going to start here because remember it didn't start the point of origin. We're going to start here, which is in a sense the point of origin for this line. So I go here, 1 increment, 2 increments. Well, I've got 2 increments, and what are the value of every increment? 3. So 2 sets of 3. Oh, let's do a wind up here. Okay, I got 1. I could also simplify by the greatest common factor they share. It gives us the same thing here. So in this situation, I wind up with not 6 over 6. I'm going to simplify it. I'm going to wind up with 1. Okay, how? Remember wind up, or we to divide by 6 down here and up here. We'd have 1 over 1, which we know turns into 1 when we do a wind up. All right, so that's the equation for letter A. Let's go ahead and erase. All right, let's take a look at letter B. Knowing the equation we know. Was it starting at the point of origin? Nope. We're talking about slope-intercept form, or y equals the slope times the rate of the whatever the value is in the x, starting at whatever point that is on the y. So let's go over here. Where does it start on the y, this line for B? It starts at 24. Nice. And it's positive 24. Cool. Got our x, I'm moving down there, but we're not worried. We want that. We want the slope once again. We want that slope. That slope is that rise over that run. So let's go ahead and make our right triangle here. So I'm going to start here at this point, slide over to here. And notice I got my right triangle. Let's go over here. Let's take care of the run. All right. 1 increment, 2 increments, 3 increments, 4 increments. And what is the value of every increment? 2. So 4 sets of 2. That's going to give us 8. Cool. Let's go and look at the rise here that forms that right triangle. I'm rising up 1 increment, but what's the value of increment? It's 3. And here's the important thing. This line is going, oh, it's a terrible line. Y'all got to work with me. It's going negative. So we go over there. It's like y equals negative 3 over 8x plus 24. If you got that one, good job. All right, so let's erase this one here. Done with it. Let's take a look at letter C. Ooh, C starts at the point of origin. We got a constant proportionality thing popping off here. So we got the classic y equals k of the constant times the value there. All right, so the rate of change. So we have y equals, well, let's find our rate of change here. Right triangle. Yes, sir. So we go over there. I'm going to run that right triangle to there. Let's go ahead and put that other end so we can see that right triangle. All right, cool. Let's take a look at the increments. 1 increment, 2 increments, 3 increments, 4 increments, 5. What's the value of every increment? 2. Okay. Then I got 2 sets of 5 is going to be 10. Cool. Let me put my x there as well. Sorry. And I'm going to rise at 1 increment. Well, 0, 1. What's the value of the increments? They're 3. So there goes my constant proportionality equation right there. So if you got that one for letter C, kind of fiery. Good job. All right, let's go on to the easy ones now here. So letter C, D. Let's take a look at letter D here. D, we have this line that's stuck on the y-axis. Where is it stuck? It's kind of like between 9 and 12. So I'm going to say maybe 10, 10.5, I don't know, 10. So I'm going to just put over here y equals 10. Of course, you put 11. You know, I'm not going to give you a hard time. 10.5 doesn't matter. So good job on that one. And so let's erase that. And let's go here. Take a look at this line. Stuck on the x-axis. Can't move. Looks like it's halfway in between 8 and 10. Y'all see? Halfway. So I'm going to go x equals 9. So there you have it. That was the answers to yesterday's do now. Okay. Rewind. If you have any questions, reach out to me. All right.